Here is a practice question on cyclic geometry. It's from 2025 mock examination. Let's browse through this question just for practice on cyclic geometry. In the diagram, VW and VY are tangents to the cycle at point P and R respectively. O is the center. This is the center. And then angle RVP, RVP, this one here, 70 degrees. And angle SPO, SPO, that's 47 degrees. And then you are required to calculate the following angles using the cyclic properties, or rather the cyclic theorems. Now let's just highlight something here. We were told that this line is a tangent to the cyclic. Similarly, this line is also a tangent. What property comes to your mind at the mention of tangents? Tangents from the same point are equal. The term called theorem, which is sometimes referred to as the alternate segment theorem. Another theorem is the term radii theorem, whereby a tangent is meeting the radius. Now, what do we know about the term radii theorem? Because this is a radius. And then if a radius meets a tangent, the angle made, it's just 90 degrees. Similarly, this is also a radius. And then the angle made, it's 90 degrees. Maybe let's check the first question. Calculate the obtuse angle ROP. ROP. It's this angle here. Now there's something you should notice here. This shape. The shape I've just circled is a kite. From tangents from the same point being equal, this side is equal to that. And then considering the fact that the PO and OR are radius from the same cycle, they have the same. So this shape is actually a kite. And the sum of the interior angles in a kite must give you 360 degrees. So if I were to put an X here, I can easily find the required angle by saying X plus 70 plus 90 degrees plus 90 degrees. It should give me 360 degrees. So this is actually X plus 70 plus 180 degrees equals to 360. So if I subtract 180 from both sides of the equation, I'm going to get that X plus 70 is actually equals to 180. That's if I subtract 180 here and here. This one will be cancelled, then this is giving me 180. Now let's subtract 70 from both sides of the equation. Minus 70 minus 70. And we know again this one is cancelled out, and you are left with X being equals to 180 degrees minus 70, and then your X is definitely equals to 110 degrees, which is the size of angle ROP, the obtuse angle required there. Next question requires us to find PQR. PQR. Let's highlight something here. This angle is no longer X, is now 110. And that's an angle at the center. Now we've learned a theorem that says that angle at the center is twice the angle at the circumference. If we want to turn into the angle at the center from the circumference, what angle is arising from the ends of the radius from the center? Now this one here is going up there. This one here, it's going up there. So this is now the angle at the circumference. And then what do we know? Our theorem is saying that the angle at the center, in our case, it's 110 degrees, is equals to 2 times the angle at the circumference, which is angle PQR. If you divide by 2 on both sides, you are going to get that your PQR is actually equals to 110 degrees divided by 2, which is equals to 55 degrees. Angle PSR, where is PSR? PSR. Now I want us to just look at something here real quick. Let me highlight something. I use this one. PSR. Let me go to onto Q and close this quadrilateral. It's a quadrilateral in a cyclic. Now what have we learned about this one? We've learned that opposite angles of a quadrilateral, of a cyclic quadrilateral, are supplementary, which means that PSR plus its opposite to the 55 degrees we've just calculated, this should be 180. That's simply they add up to 180 degrees. Now subtract 55 from both sides. And then this one is going to cancel that. And then you have your PSR being equals to 180 degrees minus 55. And then 180 minus 55 is giving me 125 degrees. So this one is just 125. Angle VSR, where is that? V, it's VRS. VRS, it's actually this angle here. So if we can be able to find this angle here, we can actually find the angle we are looking for. First things first, this angle is what we've just calculated to be 125 degrees. Now let's find this angle here. This is a quadrilateral. All angles in a quadrilateral, it will give you 360 degrees. Now let's do that. Maybe let me write it here. We have 47, we have 110, we have X, we have 125. This is equals to 360. 47 plus 110 plus 125, it's giving me 282 plus X equals to 360 degrees. Now if I were to subtract 282 on both sides of the equation, I'm getting that now X is actually equals to 360 minus the 282, which is equals to 78 degrees. So this one is 78 degrees. It's actually SRO. So the required angle now, this one is just 78. So this one is actually 90, take away the 78. Now the angle VSR is equals to 90, take away 78. So VSR is actually equals to 12 degrees. Thank you for staying tuned.